So if you take a first circle on the left, okay, and you make a copy of it and you translate it a radius away from the center. So the distance between these two centers here is a radius. Okay, so here's a second circle. You can actually, so this automatically subtends an n equals 4 Poncelet family of quadrilaterals, and you get the symmetry so that the dynamic signed area of the self-intersected family of quadrilaterals is 0 because the area of this triangle is always equal to the area of this triangle. Okay, now I've just done one experiment here, which is, let me go ahead and call this intersection point A, and then I'm going to say, I'm going to consider the triangles ABC as labeled here, and I wanted to study the triangle centers of the top triangle, the top upside down triangle, right? So one thing you notice is that X40, the Bevan center, that is to say the circumcenter of the circle that passes through the X centers, right? Or the circumcenter of the excentral triangle, is moving along a straight line. So I would like to understand why that is. That's quite a nice phenomenon here. I go like, you know, to the usual suspects like X1, the in-center, you don't get anything worth of note, nor do you get anything interesting with X2. Now notice that these triangles here are not Ponceletian. So this family of triangles is not a Ponceletian family. What's Ponceletian here is a family of quadrilaterals. So I'm breaking the symmetry by only considering ABC. But even if you do that, and you run through, you know, a few of these triangle centers, you might find some structure. For example, X4, is this a conic? You know, that's kind of an interesting thing, right? It's spanning the whole thing. And then, you know, you go through the gamut here, and you see that there's some symmetry. For example, X8 has this tangential symmetry, although it doesn't look that great, right? It doesn't look, it looks like a high degree curve. And I was just going through these things, and the first one that, yeah, let's look at X16. It's the sort of external shell kind of thing. Yeah, so you run through the gamut, and the first one that displays some amount of structure is X40. You look like at X20. It looks like X22 could be a straight line, but you can see that there's curvature here. So that one is just a false alarm. Yeah, so you keep advancing here, and when you hit 40, you get this beautiful property here. This looks pretty straight to me. So why is it that the Bevan center of ABC is sliding along a straight line? Okay, we need to determine that. See you on the next video.